Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about radiation-based detectors rely on the energy that a flame radiates in the form of waves that produce light and heat. In this graph, visible radiation, 10% of total, infrared, 90% of the total, and ultraviolet, 1% of the total, as well as those of fuel oil flame, gas, and of the refractory. The available detectors can be classified as follows. Visible radiation detectors are of two types, cadmium sulfide and cesium oxide. The first are the most used and consist of a cadmium sulfide element that varies its resistance inversely proportional to the light intensity, while the second consists of a vacuum tube that contains a cathode and anode emitting electrons when light strikes its surface. The application of these detectors requires a bright flame, and their use is limited to liquid fuel burners. They are unable to differentiate the light coming from a flame from that of other sources such as natural light, refractory, etc. Infrared radiation detectors use lead sulfide cell, whose electrical resistance decreases with increase in radiation intensity. The lead sulfide cell does not distinguish between infrared radiation emitted by the refractory or by the flame. However, the radiant energy emission of the flame has a flickering characteristic that enables a specially designed electronic circuit to discriminate between the flame signal and the uniform refractory signal. However, the movement of the hot gases in front of the refractory can simulate this flicker, exciting the cell. Ultraviolet radiation detectors consist of a tube containing two electrodes, usually tungsten. The tube is made of a material permeable to ultraviolet radiation, quartz for example, and is filled with inert gas. The operation is similar to that of the Geiger tube. If ultraviolet radiation penetrates the tube and strikes the cathode, it emits electrons that are attracted to the anode due to the electric field established between them. This process ionizes the gas in the tube, thereby conducting a current. To ensure a constant verification of the presence of the flame, it is necessary to periodically interrupt the voltage between cathode and anode. To establish the conductivity of the tube a number of times per second, since said tube represents, once excited, a self-sustaining discharge, as long as an electric field exists between the electrodes. The main advantage of ultraviolet radiation detectors is their total insensitivity to infrared and visible radiation, not being affected, for this reason, by radiation from the hot refractory, since both gas and fuel oil flames generate ultraviolet radiation. These detectors are ideal for mixed installations. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I will upload videos every Wednesday in Spanish and every Friday in English. Adiós!